Hi guys, today we're going to be looking at a question on vapor pressure of different organic compounds. The vapor pressures of different organic compounds are determined at 20 degrees Celsius. The vapor pressures of compound A, B, and C are not shown in the table. Question 3.1. Define the term vapor pressure. So vapor pressure is the pressure exerted by a vapor at equilibrium with its liquid in a closed system. Question 3.2. The vapor pressures of compound A, B, and C are given in random order below. Question 3.2.1. Write down the vapor pressure of compound C. Compound C we can see is 2,2-dimethylpropane. Therefore, it has more branches than compound A and compound B. This will cause it to have the lowest boiling point, as it has the smallest surface area, and small surface area means a lower boiling point. And since boiling point and vapor pressure are inversely proportional, compound C will have the highest vapor pressure. Therefore, it would be 146 kilopascals. Question 3.2.2. Explain your answer to question 3.2.1. So, as we've said, compound C has more branches than compound A and compound B, and it has a shorter main chain length, being propane, whereas compound B and C have butane and pentane. It therefore has a smaller surface area, and due to this, compound C has the weakest intermolecular forces between A, B, and C. Therefore, less energy is needed to overcome these intermolecular forces than the energy needed for compound A and compound B, resulting in the highest vapor pressure. Question 3.3. Compounds D and E are compared. Question 3.3.1. Which compound has a lower boiling point? So, as we have said, boiling point and vapor pressure are inversely proportional. So the one with the higher vapor pressure will have the lower boiling point. Therefore, compound E will have the lower boiling point, as it has the higher vapor pressure between D and E. Question 3.3.2. Fully explain the difference in vapor pressure between compounds D and E. So, compound D is propanoic acid. Therefore, it has hydrogen bonding, dipole-dipole forces, and London forces in its molecule. Whereas compound E, being butanol, has dipole-dipole forces and London forces only. This means that the intermolecular forces for compound D are a lot stronger than the intermolecular forces for compound E. Compound D then requires more energy in order to overcome or break the intermolecular forces, resulting in the boiling point being higher and the vapor pressure being lower. And that's all for this video. Thank you.